The theory of plate tectonics, formulated in the 1960s, is a more recent attempt to explain the movement of the continents. This theory holds that the Earth's crust is not a solid sheet of rock, but rather consists of a series of plates that float on the molten rock of the mantle. Scientists believe that there are 8 larger plates and several smaller ones. Some plates, called continental plates, have continents embedded in them. Other plates, called oceanic plates, consist only of ocean floor. Fueled by convection currents in the mantle, these plates and the continents that are embedded in them have moved and continue to move over the face of the Earth. The plates move an average of a few centimeters a year. In Activity 6, students discover that the Earth's crust is broken into pieces called plates and predict the consequences of the movement of these plates. They observe a model of Earth's crust moving as one solid piece on the mantle and then crustal plates moving independent of each other on the mantle. This activity will take about 40 minutes. The vocabulary introduced in this activity is plate. For this activity from the kit, you will need for each student 1 reclosable plastic bag, a thin sheet of cardboard, and 1 flip book from Activity 5. For the class, you will need 1 sheet of aluminum foil 30 by 30 centimeters, 2 foam balls, glue, a knitting needle, and 1 roll of masking tape. In addition to the kit materials, you will also need to supply scissors, a hard-boiled egg, a world map. Make copies of Activity Sheet 6 for each student. To prepare for this activity, make 2 models of the Earth and its crust. Push the knitting needle partway into one of the foam balls. Cut the sheet of aluminum foil in half. Shape and press 1/2 around the ball to represent the Earth as one solid mass. Make the foil cap loose enough so that it will turn around the ball. Cut the other half of the foil in half again. Shape and press the 2 smaller pieces around the second ball. Make the 2 caps, which cover a little less than half the ball. These caps represent individual crustal plates. Again, make the foil caps loose enough so that they both can move and turn independently of each other. And hard boil 1 egg. Review what students have learned to this point about the movement of the continents. Johanna, I have some foil on a foam ball right here. What do you think the foil represents on this foam ball?
Well, if we're talking about the Earth, the model of the Earth, I would say the foil would represent the crust.
Okay, I'm going to just move this crust. And I want you to notice what happens when I move that.
It all moves as one piece.
It all moves as one piece. Let's take a look at your flip book again. If you could flip through there, and let's see if that's how your continents move in your flip book. Do they all move as one piece?
No, they actually move as pieces, separate pieces apart.
Okay, well let's try 2 separate pieces of foil on our foam ball. If you'll hold this and then hold the needle right there, and I'm going to take these 2 pieces of foam and I'm going to move them, and I want you to notice what happens when I move them in different directions.
Okay, they move independent of each other, and some ways they even go fold over each other. So
how is that like our continents?
Okay, well, it might be that our continents actually, some move away from each other and some kind of move into each other, which would be an interaction of the 2 continents. Maybe one would go under the other.
Okay, well, let's take a look again at your flip book. And I want you to notice what happens to the oceans as we do this. Now, the oceans again is the white part.
Like big landmass there.
What happens?
Well, you see more of the ocean, and so the continents are moving into the body of water, so they're going away from each other. And you're seeing more evidence of the water.
Okay, so we see some oceans getting larger, some oceans getting smaller, depending on where they are on there. So what does that tell us about the oceanic plates?
Okay, the oceanic plates then are moving in opposite directions from each other.
Okay, well, let's go back to our egg model and let's think about what did the Earth's crust represent on our egg?
Okay, that was the shell.
The shell, and how is that shell different than what we've just seen on our models that we just
Well, this
used?
shell is totally enclosing the egg. There is no mobility at all of the shell around on top of the egg white.
So what could we do to get this to represent more of the Earth and move like the plates might move on our models?
Well, that shell is going to have to be broken.
Okay, so if we break it, then we might see several plates, just like our Earth's crust. Okay. Give each student a copy of Activity Sheet 6. On the map of the world, point out the area shown on the activity sheet. Tell students the activity sheet shows some of the pieces that form the Earth's crust. Introduce the word plate by telling students that the pieces of the Earth's crust are called plates. Have them name some of the continents shown on Activity Sheet 6. Ask on which plate North America can be found and what else can be found on this plate. Ask the students to identify plates that have only oceans on them, such as the Cocos, Nazca, and Pacific plates. Further explain that the North American and Pacific plates are very large and that even though they can't see the entire Pacific plate on the activity sheet, there are no continents on it. Explain that not all of the Earth's plates are shown on the activity sheet. Have students identify the dotted lines as representing outlines of the continents and solid lines as representing the plate boundaries. Divide the class into teams of 2. Give each student a sheet of cardboard and each team a pair of scissors. Pass out the glue bottles and have the students glue the activity sheet to the cardboard. Tell them to cut along the plates along the plate boundaries and reassemble the plate puzzle on their desk. Johanna, we have a plate puzzle already assembled here. Let's take a look at the arrows. What do you think the arrows mean on this puzzle?
I would say that the arrows probably indicate the direction that the plates are moving.
Let's just pretend like we're going to move the plates, and let's move each plate in the direction of the arrow about 2 centimeters or a little less. Now, this one goes this way.
Uh-oh, okay, this one goes this way. This one comes up here, but what am I going to do here?
Well, they kind of bump each other, don't they? Let's move these the direction that they say, 2 centimeters. Now it'll come this way, that way. Okay, and then let's take a look at the Pacific plate, the Cocos plate, and the Nazca plate. What do you see happening around these plates?
Well, they seem to be going in opposite directions.
And we are left with this big gap right there. And when the students see that gap right there, we want to ask them what they think is going on in this gap.
It appears that water would be filling up this gap.
And will we see gaps between the continents like this? I mean, there's not, as you know, the water fills in.
Yeah. But, there might be gaps there. How would we find out?
Well, and then when we go back and look at that Nazca plate and that South American plate, and we see again those pushing against each other.
Wonder what would happen there.
If they push hard enough, that might be something that we're going to want to take a look at later on in future activities. Tell the students that they now have 2 mysteries to solve. Write the heading Mysteries and ask the students to tell what the 2 mysteries are as you record. Students should be able to give a similar version of why don't plates that move apart leave a gap in the earth? And what happens to plates that move toward each other? As you write the 2 mysteries, leave space to add information as each mystery is solved. Explain to students that these same mysteries have puzzled scientists who study plate movement, and that in the activities to come, students will attempt to solve the mysteries. For cleanup, discard the egg and foil caps. Give each student a reclosable plastic bag and a piece of masking tape. Tell students to put their plate puzzles in the bag and label it with tape. Collect the plate puzzles and flip books for use in later activities. Return the glue, foam balls, and knitting needle to the kit. Leave the mystery charts up for the students to think about over the next several activities. guide the students through reading pages 6 through 8 in the Delta Science Reader.